Welcome to this Protastructure training. Before we go fully into the Protastructure training classes, I would want us to get ourselves familiar with the Protastructure software. And in doing that, we need to ensure that we have the fundamentals, that's the basic knowledge of structural design. As we all know, it is important that you must have gone through um, the basic principles or have a basic knowledge of what structural design is, either by way of going to study a course like civil engineering or the likes in an institution of learning. From that, you will have been introduced to the manual way of doing structural analysis and design. Now we will still need that knowledge that you were able to acquire in your school or in your university. We will need that knowledge to be able to um, use Protastructure effectively. It is important, number one, that you have the fundamental knowledge of structural design. You have the basic knowledge. You have run a course on structural design, so that by the time we are going into the use of Protastructure, it will be an edge for you to truly understand what is required to have a safe and economical structure. All right, so to start with, we'll be going to define what structural engineering is all about. So, structural engineering is actually a branch of civil engineering that is focused on designing buildings, dams, bridges, etc. To in such that they are safe, they are stable, and also strong to withstand loads. Just as you know, in the manual kind of design, you always put safety into consideration because that's the main idea behind it. Your structure must be safe, it must be stable, it must also be strong to withstand all kinds of load, whether dead load, imposed load, wind load, all kinds of load that you can mention. Now, some of the things that needs to be put into consideration when you are designing, which I'm very sure you have a basic knowledge of this, having gone through um, either a civil engineering course or related courses. Now, the first consideration that has been put in place in structural engineering is safety and stability, meaning that your structure should be stable and also safe. As you know very well that by the time a structure is being built or a building is completed, we will have human beings and other um, properties within the confinement of that building. So it is important that you design for safety, as in you design in a way that the structure is what, or the building is safe to be occupied by both human beings and all other kinds of properties. Also, serviceability is also another consideration when designing, as we know that serviceability actually refers to the ability of structures to perform their intended function during its lifetime. That means during the life time of the structure that you design, it should be able to perform every of its function effectively without failure. The next consideration is economy. When you are designing, even though safety comes before economy, but you should also consider economy. It's very important in design. After safety is economy. Don't put economy first. No, safety must come before economy, but you must also consider economy. Just for instance, now, if I let me compare safety and economy. Now, if I design the structure um, to have to be using a reinforcement bar of maybe let's say 12 mm for the slabs, the solid slabs that were designed. In the design, it is recommended that you use a reinforcement bar of 12 mm. Now, during execution, using a reinforcement bar of 10 mm is very, very risky and unprofessional. It shows that safety has not been put in place. Okay, this the design actually said 12 mm reinforcements for the solid slab, and then during execution, 10 mm was used. It shows that safety was not considered, and that could be a great issue um, for the structure, meaning the structure is not safe. But when it comes to economy, let's say for instance, I designed um, my beams or even the slab to use 8 mm rods. Let's use our slabs. Maybe I designed my slab to use 10 mm rod. Let's use 10 mm. And during execution, 16 mm rods were now used. Now you can see that this will mean more cost because we all know that 16 mm rods are much more um, higher in cost than 12 mm. So using 16 mm instead of 12 mm shows that we have not put economy into consideration. Since my structure was designed for 12 mm reinforcement bars, using 12 mm reinforcement bars instead of 16 mm reinforcement bars shows that I have considered economy. So, like I've said in the first place, safety and economy are two things that a structural engineer must put um, into consideration, but safety comes first before economy. So, in event that um, I'm in a situation where I have to choose between safety and economy, I must always choose safety. The next one that we're talking about is function and aesthetics. During design, the structural engineer must ensure that he maintains every aspect of um, the design handed over to him from by the architect. Okay, that means as you are doing your modeling or your design, you must ensure that every details that were in the original architectural drawings are maintained, except um, in except if conditions arise whereby the safety of the building will be compromised. That is when altering the aesthetics of a building can be considered. If not, as a structural engineer, you must ensure that you um, follow what was given to you in the architectural design without just altering things just to satisfy yourself. No, you don't do that. You ensure that you follow everything, unless if um, the safety of a structure will be compromised. That's when you can um, alter some vital things in a structure. All right. So from here, we can now go to structural loads. Okay. So from your background in civil engineering or related courses, structural loads are forces that are acting on a building on or on a structure. And some of the loads that we have are dead loads. Now, dead loads are the weight of the structure itself. It may be for the walls, the roof, and the foundations. These are particularly fixed elements. Now we have live loads, and now these are loads from the occupants, from furniture, and also from equipment. We have environmental loads, which are loads from the wind load, rain load, snow, rain loads, seismic loads, and etc. Every one of these must be considered, taking into consideration the kind of environment. Like there are particular kinds of loads that we'll consider in Nigeria, which may not be considered in Europe. And there are some kinds of loads in Europe, like snow loads, that needs to be considered that may not be considered in Nigeria. For instance, in Asian countries, seismic loads needs to be considered because of earthquakes. But in Africa, we don't really consider seismic loads because we don't have occurrences, earthquakes happening around here. Okay, so the next we'll be looking at the scope. That is, what is the scope of this tutorial? Now, this tutorial is actually limited to building structures only. As you know that we have all other kinds of structures. We have bridges, we have dams, etc. Now, Protastructure is actually meant for um, building structures, but can be used to do other things, other structures also, but mainly it is limited strictly to okay, scope of this. Now, the scope of this Protastructure tutorial will be limited strictly to building structures alone. As you know that we have other kinds of structures like bridges, dams, etc. Now, this tutorial will actually be focusing on the analysis and design of typical elements such as beams, columns, foundations, and slabs. And other related structural components will not be covered in this tutorial, such as bridges, roads, industrial plants, and also non-industrial building structures. As you know, other non-building. Okay. Now, protest structure can also be used to do other kinds of design, like maybe for plants or um, other non-building structures. But particularly for this tutorial, we'll be restricting it to building structures. You can also use protest structure for foundation design. Okay. Now, foundation design will also be restricted to pad footings, and you can follow our links in this same tutorial if you would like to learn about other kinds of foundations. We have, as you know, we have deep and shallow foundations. So for a deep foundations such as piles, you can follow us so that you'll be able to learn how to design these kinds of foundations, whether it is deep foundation or raft or shallow foundations, such as raft foundation. Okay, so structural elements in Protastructure. When you talk about structural elements, we are talking about columns, beams, slabs, and foundations. Now, what are columns? Columns, we know, are vertical members that are responsible for transferring loads from the slabs and beams down to the foundation. While beams, they are horizontal members that support our slabs and then they transfer loads down to the columns. So in Protastructure, beams are actually being analyzed for bending and shear and also deflection under applied load. So as we progress in the use of this software, you will see how all these things come into play. So the software automatically generates reinforcements based on load combinations, and it also ensures compliance with design codes. In this tutorial, for with Protastructure, as usual, just as in your manual design, we'll be using VS Code 8110 during our design. And also we have other BS codes that are used. All right. So key requirements before starting structural design. Now, before a structural engineer or a just graduated engineer begins any design work, there are certain essential terms and considerations that must be put in place. These form the foundation for a safe, economical, and code compliant design. If you note that it says this form the foundation for a safe, economical, and code compliant design. So it is important that some very key things, some very key considerations are put into place before your design can start. Now, let's talk about our architectural drawings. Now, the engineer must have approved architectural drawings, including floor plans, elevations, and sections. Ensure that your drawings, which is the drawings given to you by the architect, are approved. That means they've been stamped and also approved by the agency in charge. Now, a structural engineer must be familiar with relevant design codes, such as what we have Eurocode, BS, ACI. Now, these are codes that guide loads, value, and safety factors, material properties, and detailing requirements. It's important that you are familiar with such codes. Like in Nigeria, I'm very sure that if you have gone for a civil engineering course, there's no way you would not have been acquainted with the BS code. So that is the code we'll be using um, particularly in this tutorial. Now we have material properties. Another thing you need to be acquainted with is material properties. Now you need clear information on materials that are to be used during a project, such as your concrete grade. As you know, we have different kinds of concrete grade. Steel reinforcement grade. You also need to know more about your steel reinforcement grade. There's no way you have gone through civil engineering course that you will not hear anything about concrete grade. Okay, so it's important before you start any design. It's important that you have basic knowledge of all of these things. You're not even allowed to um, do design if you don't have the solid background, like being from uh, a civil engineering background. Okay, so you should know the steel grade, you should know the masonry type that are required, and their properties will definitely affect the strength and durability and overall performance of a structure. We don't just use any kind of materials. We don't just use any kind of concrete grade. We have specific grades for specific components. Like if I'm designing for um, my foundations, the kind of grade I will use there may be different from the grade I will use for my oversight concrete. So, concrete grades are very, very important and should be considered. And this part is something that you must have a profound knowledge of before you start your design. Now, the engineer must understand all loads acting on a structure. You must have great knowledge about loadings on structure such as dead loads. You know what a dead load is, you know what live loads are, you know what wind loads are, and then you know where you need to apply them. If you have been doing manual design as you have been taught in school, or have been doing manual design over the years as a structural engineer who is just trying to learn how to use um Protastructure, you should be able to know when to apply any one of these loads during design. Now, you should also know of accurate load assessment. Y- Okay, accurate load assessment is also critical to ensuring structural safety. All right, another essential item is soil and site information. Now, this is also a very critical aspect that in Nigeria we take for granted, and it shouldn't be so. Site soil and site information. Now, soil bearing capacity and ground conditions must be known before designing foundations. Don't just go into designing your foundations without having your soil report from a geotechnical engineer. As you know that civil engineering has various branches. On one branch is geotechnics. Okay, geotechnical engineering. You should um, you should be given the details of the soil report of the particular environment you'll be executing the building in order for you to use for your foundation design. Let me come again. Before you can do your foundation design, the soil and site information report should be handed over to you, because you'll be using that during your design. So it's a must. Always cultivate that habit as a structural engineer to ensure that a proper soil test is done before you go further into design. For instance, if you are doing a pile foundation, there's no way you can there's no way you can start your design without having a soil report. Likewise, for every other kinds of foundation, we must always do that. Stop guessing. Guessing is not good. There are sites that could have um, varying soil bearing capacities, and then when you now generalize it, at the end of the day, you see that settlement begins to occur, and at a degree that was not expected, all because proper soil tests were not conducted. So that is just another item. Okay. So we'll be discussing also about important things to know about beam and column orientation. Now, correct beam and column orientation is very important during structural modeling because it affects load transfer. You don't just insert columns just anywhere or beams anywhere without considering load transfer. Load transfer is very, very important because if your loads are not properly transferred, it will definitely cause failure. Now, analysis results and reinforcement designs are also very important during structural modeling because it affects, like I said, your load transfer. Okay. All right. So let's talk about column orientation. Now, columns are not just vertical lines. They have cross-sectional directions, major and minor axes. Columns must be what oriented correctly to match architectural layout and load direction. The axis of a column should generally align with the direction of higher bending moments. Now I'll be showing you what that means. The strong axis of a column should generally align with the direction of higher bending moments. Now we'll be putting this particular consideration into play when it comes to um when it comes to when it comes to um rectangular columns. Okay, as you know, we can have a column whereby the section is the same, maybe 225 by 225, and we may have another one which is a rectangular column 225 by 450. Now those are the ones we that this is applicable to, whereby the strong axis of a column should generally align with the direction of higher bending moments. Okay, incorrect column orientation can reduce load carrying capacity and lead to inefficient reinforcement design. During modeling, always check column dimensions. For example, a 300 mm by 600 mm rectangular column must have the longer side facing the right direction. Okay, so we'll be looking at column orientations. Like I said, column orientations are um, dependent on the type of column, okay, available at that point. So we can classify columns into three categories: axial columns, uniaxial column, and biaxial columns. Now, axial columns are subjected to equal forces in all of the four dimensions. So for you to know that a column, okay, these are column, if you want to know if it is an axial column, then it must be subjected to equal loads in all the four directions. Like if you look at this, we have a beam here, we have another one here, we have another one here, we have another one here. Now, all of these beams are of equal length. That means the dimensions are the same and also of equal length and are exerting the same compressive force on this particular column. Now, that makes it an axial column, meaning that there will be no bending because each of the forces being brought from each of the column is countered by the other beam. Okay, that means each force coming from, like the force coming from this side, since it's equal with the beam, uh, the force of the beam coming from this side, it counters the compressive forces coming against this column. The compressive force from this side and also the compressive force from this side counters itself, because these beams are of equal dimensions. And bending, therefore, there is no bending. That means bending does not occur around this column, whether in this direction or this direction, all four sides, as long as the dimensions of the beams are equal. There can be no bending. All the bending is countered, meaning that this is an axial column. An axial column. There is no bending in axial columns, and it is subject to loads in all directions. This is when you know that a column is an axial column. Now we have a uniaxial columns. Now, uniaxial columns are subjected to loads in three directions, like you can see in this: one, two, three. Now, this column is subjected to what? To loads in three directions. Okay, when we count, we just counted one, two, and three. And then it is subjected to bending in one direction. Like in this direction now, there will be bending on this column. Okay, because there is no other beam that can counter the compressive force being exerted by this beam. Then it means that there will be what? There will be bending in this direction. So this makes this to be a uniaxial column. A uniaxial column, like I said, it subjects load in three directions and subjected to bending in one direction. All right, let's go to a biaxial column. Now, biaxial columns, unlike the other two, biaxial columns are subjected to loads in two directions. If you look at this direction one and then direction two. Okay? And then they are also subjected to bending in two directions. Now, in this direction, this column is subjected to bending. There is no force that is going to counter this force that is being exerted by this beam. So there will be bending in this direction and also bending in this direction. Now I will be explaining further how all of this affects our column orientation. That is when we will now go back to this statement that says the strong axis of a column should generally align with the direction of higher bending moments. Now, if you look at this now, the point of higher bending moments in this part is this. Okay, this is the point of higher bending. For this one, this is the point. We have one point of higher bending here, and we have another one here. But now we cannot just select one of it as the highest point of bending. We still need to investigate and know which of these beam for this biaxial column has a higher moment. Okay, if it is this one that has a higher moment, then this this statement has to be in play that the strong axis of a column should align with um direction of higher moments. So if it is at this direction that has a higher moment, then the orientation of this column will be in such a way that it will be in this direction. I'll still explain that further, but I just wanted to know how to identify types of column because it helps us to know very well about column orientation. All right, so let's go here now. Now, you will note that this column orientation explanation, it is applicable in rectangular columns only, meaning that if we have, this is a rectangular column, if we have columns that are just sized within the beam, maybe 225 by 225, it is not applicable. Column orientation, where we don't need to apply this rule that I highlighted here, whereby the strong axis of the column should generally align with the direction of higher bending moments. Because at that point, it is already within the beams. But Here now, when it comes to rectangular columns, it is required that we apply that rule. Okay. Okay, so if you look at this floor plan and you look at how the columns are placed, you can be able to determine which one is an axial column, which one is a uniaxial, and which one is a biaxial column. All from what I described to you. Okay. So if you look at this one now, you will see that this column is subjected to a load from this beam and also another load from this beam. Okay. So um we can see that it is subjected to load in two directions. So we can consider this um column as a biaxial column. Why? Because it is subjected to load in two directions. Okay. This column will be subjected to bending here and also bending here. Now, but you would now see that this particular beam is longer than the beam here. Okay. So in order for us to be able to orient our rectangular column, it must be in the direction of the one that is longer, since this one will subject it to a higher load than the beam at this side. So when we want to orient it according um to this statement, it said the strong axis of a column should generally align with direction of higher bending moments. So we are going to align this column to direction of higher bending moment, because there will be a higher bending moment from this beam because it has a large a higher span than this one. So it is definitely going to subject it to a higher bending moment. So the orientation of this rectangular beam will be such that its longer part will be in the direction of this one, since it's exerting a more higher moment than this one. Okay, so if we look at this column also, you will see that it applies. But the thing is that as a structural engineer, I used to tell you, you must be able to understand a lot of things. Now, if we want to apply what we just did to this one in this case, you see it may be slightly different when it comes to this. Now, for this beam, this is the dimension of this beam. It's a 225 by the length is 3000. Now, the length of this beam is 45 millimeters, 4500 millimeters, and this one is 2500 millimeters. Now, this particular beam is exerting a compressive force on this column. Likewise, this one. But this one has a higher moment. It's exerting a higher moment than this part. Okay, so it has not been able to counter, this particular beam has not been able to counter the force coming from this one. If you look at it, 2500 and 4500, you will see that this one will still have what? Much excess moment. Okay, so if now have to we will now have to consider the moment from this part. Now, what kind of column is this? You can say that we say that columns in which loads are subjected in three directions are called uniaxial columns. So this is an example of a uniaxial column because we have loads in three directions: one, two, and three. Okay, so now we will now orient our column in such a way that it is in the direction of the one having the highest moment. But you will not ask, this one seems to be longer than any one of them, so it should have been oriented in this direction. But no, we will consider the fact that part of the moment this one is exerting on this column has already been countered. Part of it has been countered by this one. Okay, so the moment exerted on this column will now have to be compared with the one exerted here. So let's say, for instance, this is having, let's say it is exerting a load of we have 4, 5 here,
and then being countered by another beam of 2.5. The moment will have reduced. Okay, the moment at this point will have reduced, and definitely a moment of exerted by a beam of, let's say, 4.5 minus 2.5, that is a beam of, the remainder is 2000 mm. The moment exerted by a beam of 2000 mm will definitely be lower than the moment exerted, that's a compressive force, by a beam of 3000 mm. So the orientation of this column will definitely be in this direction. Now let's look at this column. This column is an example of a biaxial column. You know, we said biaxial columns are subjected to loads in two directions, and we have load in this direction and also in this direction. Now, the orientation of the column will be dependent on also the compressive force, okay, exerted. Now, we know that definitely a beam of 3000 mm will exert more moment than a beam of 2500. So the orientation will be in this direction. Okay, so let's look at this one. I know from the look of it, it looks as if this should be an axial column. Okay, you know, we said an axial column is a column that's subjected to load in all four directions. Now you must note one thing, not just load in all four direction, but equal load. That means this load coming here must be equal to the one coming here before, must be equal to the one coming here, must be equal to the one coming here before it can be considered as what? An axial column. That means there will be no bending because the load coming from here is countered by this one. The load coming from here is countered by this one. So there is no bending at all. That's the only condition that makes it an axial column. But in this case, if you look at the load coming from all four ends, you will see that the moments from each of these cannot be equal. Here now we have a beam of 4,500 exerting um, bending moment to this column, and then this one of 2.5 exerting a force, compressive force to this side. Then we have 3000 and we have 3000. Now, these two have countered, okay? So meaning that there is no moment along this part. But when it comes to this one and this one, you will see that the moment being exerted by this beam will be higher than the moment exerted by this beam, meaning that we cannot consider this one as an axial column because it is not having equal loads in all direction. There is only equal load in this direction and also in this direction. In this direction, there is equal load, which means that it has what? There is no bending in this direction, but in this direction, there is bending because the load being exerted from this is higher than the load being exerted from this beam. And in such instance, you have to orient your column in such a way that it goes in, okay, into this one that has a higher load, so that we can satisfy this statement that says the strong axis of a column should generally align with direction of higher bending moment. So this one, this direction has a higher bending moment than this one. So the orientation will be such, the orientation of the column will be such that it goes into the side much, it goes further, much further into this beam than this beam. Okay, so that's just the principle you apply when you are orienting um, a rectangular column. It doesn't apply when it is a circular column or a square column because they are all within um, the beam. So that is just that about um, column orientation and identifying the type. So column orientation depends largely on the type of the column. All right, I believe you understand that because it's very, very important. If you miss this, it will mess up the load transfers, okay, in your structure. Most especially when you have places that have rectangular beams. You have to be very careful. Haven't talked about column orientation. We'll now go into beam orientation. Now, in your beam orientation, you must orient your beam in such a way that the depth must be oriented vertically. It cannot be sideways. That means it cannot be in a horizontal form. No, it's no longer a beam. It is the depth, the vertical depth of a beam that makes it what? A beam. So beams must have their depth oriented vertically. And then it must also have its the beam must be framed properly into columns. And this is to ensure um a clear and continuous load depth. Number one, when you are placing your beams must be oriented vertically. It is not sideways. If your beams, if you do it sideways, then that means there is no there is no need for a beam there. The strength of a beam is it being oriented vertically. So it must have a depth. That is what makes it a beam, and that is what makes it effective. And then it should properly align, it should be properly framed into your columns. And this is to ensure a clear and continuous load path. Also, another thing you need to note is connection between beams and columns. Now, orientation what ensures good connectivity. Beams must connect at correct face of columns, not just their center lines. Misaligned members can cause unrealistic force distribution in the analysis model. Okay, then slab load direction awareness. Now, beam orientation should follow slab behavior. One-way slab should span in the short direction with beams provided accordingly. And also two-way slabs should distribute loads in both directions. So beam layout must reflect all of this. Now, these are things that are very, very critical. You can pick up any all of these things, and then you research on them individually and understand them in depthly, because they are very, very important during design. Also, global axis and local axis, consistency across floors. The orientation should be consistent. You should have consistent orientation of your beams. Don't have um just having larger beam, maybe on a particular floor or on a particular slab, you are having varying depths. It's not professional. You should avoid that as much as possible. Orientation should be what? Should be consistent. It should be consistent from floor to floor. So sudden changes in beam or column orientation between levels can create structural irregularities and design complications. So the next one is, like I said, is consistency across floors. Make sure that your orientation is consistent from floor to floor. Avoid sudden changes in beams or column orientation, that is between floors, because it can create structural irregularities and beam and design complications. Okay. Then another one is engineering judgment over software assumption. Okay. Software will analyze what is modeled, not what is intended. Okay. It is what you give to it that it gives back to you. It may not be your intention. So that's why you need to be very, very meticulous. You need to know exactly what you're doing. That's why a very good foundation in engineering is very important. Even before you start using your softwares, you should have an in-depth knowledge of how to design manually, so that you will understand and appreciate that the software is only to make your work faster, but not as if it's taking over everything about manual design. So engineering judgment over software assumptions. Make sure that you are in control as a software, as a structural engineer. You must be in control of the software itself. Now you cross-check member orientations before you start your design, section dimensions, and alignment before running your design. All right. All right, so the last thing we'll be talking about are the four stages in Protastructure, which is modeling, analysis, design, and then detailing. Just put this at the back of your mind that these are the things that you will be doing once you want to design using Protastructure or any other uh, structural engineering, structural design software. You model. After you model, you analyze. After you analyze, then you design, and after design, you detail. So it's what the result of your detailing is what helps you to be able to execute the project proper. And every one of this stage is very, very important to ensure proper design and having a safe and also an economical structure. So the first stage is, I call it MAD, okay? MADD, modeling, analysis, and design. All right. I hope we'll have a smooth ride through the training class with all of this in place. If there is any other aspect that you are not sure about, you can send me a DM. You can contact me either on YouTube, on Facebook, or through WhatsApp, or via the number that you'll see at any point in time during this video. So it's important that, like I said, you have in-depth knowledge. This is just me trying to brush you up to make you understand that your knowledge of manual design is not a waste. It's just um, it's just you using it to it's just you using structure to make your work faster. So don't see it as if you don't need your manual design. You don't need to know more about manual design. No, manual design is a very, very good foundation, and you need to be acquainted with it, because using structure without that knowledge, it's very, very risky, and should not be encouraged. Okay, so we'll be moving to our next video, which is getting ourselves acquainted with the structure interface. See you.